Hello, this is Math with Beth, and we are going to do the chain rule for finding derivatives. So the first thing that you're going to need to get good at is just identifying when you have a composition function, because that is what the chain rule is used for. So here's kind of the fancy way of writing it, but then I'm going to give you an easier way to think about this. So if you have a composition function, something like f of g, meaning you have one function inside the other, the way you're going to do the derivative is taking the derivative of the outside function, so in this case the f, times the derivative of the inside function, which in this case would be the g. So I know all of this notation is a little overwhelming. So I'm going to hopefully help make it a little easier. So first, let's try to recognize when we even have a composition function, because they're not going to come out and tell you. So in this case, we have 3x to the fourth plus 4x to the third minus 3 over x. This is a very simple, basic equation. Only the x is being raised to the fourth. Only the x is being raised to the third. This is something where we can just use the power rule. We do not need the chain rule. This is a little more complicated, but we still just have x's being multiplied and raised to powers. We just happen to have one on top and one on the bottom. So this would need something a little fancier, but still not the chain rule. Finally, do you see a difference here? That we have a function 3x plus 2 that is all being raised to the fourth. So this will need the chain rule. So I'll come back and do that in a second. This one, same idea. Do you see that we have this function all inside the square root? So that's a function inside a function. So hopefully you kind of see what we're looking for to decide that we need the chain rule. These are composite functions. The other ones weren't. So if I wanted to do the derivative of this one, what this is telling me is do the derivative of the outside thing first. So this is my inside function, the 3x plus 2. The fact that it's being raised to the fourth is the outside function. So the first thing I need to do is figure out what would I do if I have something to the fourth power? Well, here's where we would normally put the 4 in the front of whatever we have. So I'm not touching the 3x plus 2 yet. I'm just bringing the 4 out front and then subtracting 1 from the 4. So it's just like we do for the power rule, but I'm doing it for this whole entire large function. So that is this. Now I need to multiply by the derivative of the inside. So multiply by the derivative of whatever was inside, which is the 3x plus 2. So hopefully you find that the derivative of 3x plus 2 would just be 3. So this is the derivative of the outside times the derivative of the inside. This is my answer, and most instructors are fine with you not going too much further, but you definitely could multiply the 4 and the 3 and at least go to here. And that's probably fine. Let's do the next one. Now that we've decided this one is also the chain rule, we can do the inside and the outside function separately. But the first thing you might want to do is remember that with square roots, don't we normally rewrite them as something to the 1/2 power and then do the derivative? So same thing here. So now I'm ready to do the derivative by doing the outside part first, which is the fact that this stuff is being raised to the 1/2. So bring the 1/2 out front and then subtract 1. And that is me taking the derivative of the outside part. So now I need to multiply by the derivative of the inside part, which would be 10x minus 3. Again, there's not too much you could do other than maybe multiplying the 1/2 times all of this, but it's not going to be that pretty. So I'm just going to stop there. If your instructor wants you to go further than that, you can now go further than that. But this is the chain rule. So let's look at the next one. The next one has a lot going on. First, it looks like I would maybe use the quotient rule. But then I do have a function here inside another function. So the first thing I'm going to do, just because I don't love the quotient rule, is I'm just going to rewrite this like that, because now I don't have to do the quotient rule. So now I'm just going to focus on the outside function and the inside function again. So I'm going to do the chain rule. So outside function means bring this -3 up front and then subtract 1 from it. Inside function is 0 minus 2x. So I could combine those two to get 30x. And I could now maybe put this back on the bottom if I want to be fancy. But again, the main point of this video is the chain rule. So hopefully you see how I handled the outside function, which is something to the -3rd, and then times the derivative of the inside. So let's do another one. This one's a little simpler. It's already something to a power. So I'm going to handle the outside part first, which means bring that -50 out front and then subtract 1 from it. But now the extra step of the chain rule is always multiply by the derivative of the inside, which in this case would be 8x plus 0. So just 8x. So again, I could definitely multiply the -50 and the 8x. And since this had a negative exponent, I could again go ahead and move that to the bottom, because we usually don't want to leave negative exponents. Okay, so that is the chain rule. It obviously is going to take some practice. So now I'm going to do some of the more complicated ones so you can at least see where you're headed. These are some of the examples where the chain rule is happening either more than one time, or there's a chain rule in the middle of something else, like a product rule or a quotient rule. So for number 1, do you see that there are clearly 2 different functions with x's being multiplied? So that tells me I'm definitely going to need the product rule. But at some point when I'm doing the product rule, I'm going to have to take the derivative of this here, and this is definitely a function inside another function. So I'm going to need the chain rule also. So let's just start finding the derivative. Derivative, so if you want to call this f and this g, just to keep things straight, I'm going to do f as it is times the derivative of g. But since, like I said, this is a composition function, I need to do the chain rule. So outside function means put the 5 out front and subtract 1. Inside function now means multiply by a -2. So this is my f, this is my g prime, excuse me, excuse me, plus, so this is f, this is g prime, plus g, which is this, times f prime, which would be 3x to the second. Again, it's up to your instructor on how nice they want you to make that. So I'm just going to stop there and at least make sure you understand how to sometimes use the chain rule in the middle of the product rule. So let's just try that one more time. This is again clearly 2 things being multiplied, so product rule. But when I deal with the derivative of this, do you see that it's a function inside another function? So first thing is with derivatives, we rarely like a square root. So that's my first step, is just rewriting the problem in a nicer way. Now I'm going to do the product rule. First function times derivative of the second, which is where I need the chain rule. So multiply that 1/2 in front and subtract 1 from it, times derivative of the inside, plus second fraction as it is, times the derivative of the first. Once again, up to your instructors how nice they want you to make that. So if you just need some examples on how to simplify stuff like this, maybe just send me a message and let me know, and I'll give an example or a couple examples on making these nicer. Last one though, this is clearly a composition because there's a big old function in here raised to the 6th power. But when I go to do the inside part eventually, do you see I have another function inside a function? So we're going to end up needing the chain rule twice. So let's talk it through. First step, outside function, all of this being raised to the 6. So I take the 6 out front. All of this stays the same for now. So just the 6 went to the front, and now I do 6 minus 1, 5. So that's it as far as me handling the outside part. Now I'm going to multiply by the derivative of the inside, whatever that happens to be. So in this case, that part's easy. 3 goes out front. So 6x to the 2nd plus, now I need another chain rule to find the derivative of this. So handling the outside part is the 2. Bring it out front and then subtract 1 from it. And now the inside part is 4. So this was the outside part of the whole thing, handling the 6 out front, making it a 5. This was the derivative of the inside, but part of that involved me doing another chain rule. So as you can see, these can just get more and more complicated. So there is not one way that they're always going to look. So you really have to get good at talking yourself through. Are you doing a product rule? What are the different steps? Are you just doing a very big chain rule? What are the steps? And if at some point you have to do a derivative of something else that's a chain rule, you got to do it again. I hope that helped, but obviously to start with the chain rule, I would go back and do more simple examples that just have one function inside of another function before you get to the complicated ones that have a lot more going on. I hope that helped. Let me know if you need more.